Hello everyone around the world. So today we are not fixing anything, but let's speak about other things. If you check on the channel, we fix more than 150 laptop motherboards, various faults. So from the comments, I can see people what they understand and what they don't understand. I try to explain how laptop motherboards are working, how we are diagnosing faults, how we are fixing various kind of laptops. Laptops might be different, but the diagnosis procedure is almost the same, except on few model of laptops like MacBooks and other stuff where you have to look for schematics and others in order to know how the power sequence they are working on that particular laptop. So here we have an issue. The issue is like that. When the 19 volts power rail is missing on laptop motherboards, it's very easy to bring it back. It's very easy to bring it back, whether you have a short or the MOSFETs, they are not passing they are not passing the 19 volts. Maybe we have a dead BQ chip or one of the MOSFETs is shorted from drain to source. It's very easy to bring the 19 volts back. But from the comments, I found a big challenge. When the 3.3 volts is missing, fine, you have 19 volts on all power supply. But most of technicians, they found it hard to bring back the 3.3 volts power supply to life. Because most of the problems, they come from the 3.3 volts. Because this power supply is always off. When you think your laptop is off, but this power supply is up and running. So the story is like this. Here we have the motherboards. These are motherboards for space. We are not going to fix anything, but let's speak about the EC chip. How the EC chip is working. The embedded controller. Some they call it EC chip, startup chip, microcontroller. You see this chip, the bigger one. On every motherboard, you have a controller there. So by end of this video, we must know what this chip is doing, how to check this chip, and what are the conditions to replace the EC chip. Let's pay attention to the EC chip. Let's ignore other things and concentrate on the EC chip, because from this chip many problems have been arise over time, and people, they found it hard maybe to replace the chip or maybe to diagnose missing 3.3 volts power supply and bring it back to life. Okay, so let's do a little bit of theory and you will see more about this chip. Just a little bit, not too much. So here we have a laptop motherboard. Here we have a laptop motherboard like this. That's the laptop motherboard. Fine. On this laptop motherboard, we have 19 volts, we have 3.3, we have 1.5 volts, we have 1 volt, we have 5 volts, but the 3.3 volts is always on laptop motherboards. So one of the many important chip which is working with 3.3 volts is the embedded controller, the EC chip. So here we have our EC chip. That's the EC chip. Some they call it microcontroller. Some they call it startup chip. Startup chip. This chip is working with 3.3 volts. And in order to have this chip working, we must have 3.3 volts. And this 3.3 volts on some kind of old laptop motherboard, we have a BIOS chip. We have a BIOS here. That's the BIOS. And from the VCC pin of the BIOS chip, that is pin number 8. Pin number 8, that's the VCC pin of the BIOS chip. The EC chip is connected with this VCC pin. If you put your multimeter on diode mode and you check from the VCC pin to the EC chip, you must have like a 0 resistance on one of the pins. Because this pin number 8 is going straight to the EC chip. And where this pin number 8 is getting this 3.3 volts, is getting it from the 3.3 volts power supply. It's getting it from the 3.3 volts power supply. And from the 3.3 volts power supply, you have many chips here. You have, trust me, you have many chips. You have RT 8208. We have a TPS 51225, 51125. We have a 1225C. We have a 512223. We have so many chips, trust me. We have so many chips, and all these chips, they are regulating 3.3 volts, which is always on. So the BIOS chip is getting 3.3 volts from the 3.3 volts power supply from this driver, and is getting it not from the coils. It's getting it from the VREG 3. From the VREG 3, the BIOS chip is getting power and straight to the embedded controller, our EC chip. So even if the laptop is off, as long as that laptop has a working battery, this chip is always under the power, and the VREG 3 is always on. We have VREG 3, we have VREG 5, but on this moment, we want to concentrate on the EC chip. So the EC chip is getting power from the VREG 3. I think that is straightforward. So I found many issues. You have 19 volts and the 3.3 volts is missing. You see this chip, this regulator getting hot. You test it, even if you didn't come with any amps, you feel it, the chip is getting super hot. You think this chip is fault. You are very wrong. Maybe it can be fault. In electronics, anything is possible. The chip can be faulty, can be hot and still be faulty. But in most cases, based on experience, I found this chip getting hot because here we have a short. The EC chip is shorted on the VREG 3, and this chip is taking that current, because this chip is working with around 100 to 120 to 130 milliamps. This is a low output power supply. So this chip can be hot because here we have a short. So that's the thing about the power sequence on how this EC chip is getting powered on. Furthermore, from this chip, what this chip is doing is handling power supplies. It's handling various power supplies here. We have 1.5 volts. We have 3.3 volts. Not this one, for the PCH probably. We have 5 volts. We have maybe 1 volt for the CPU. It's like this chip is handling all the power supplies, including the power on button. And on the power on button, I found a resistor. We have a resistor here. We have a signal which is coming from the EC chip, and we have a resistor. And on some kind of laptop models, some kind of other laptops models. Here we have a 1 microfarad capacitor, which is the one side is connected to ground and the other one is to 3.3. And after that, that's our switch. That's our power on button. That's our power on button, a switch. And the condition for this switch to start up the motherboard is to send 3.3, because here we have a pin which is carrying 3.3 volts, is to send this. When you press the switch button, this 3.3 is sending to ground. That just once, the 3.3 will be sent to ground just once. And on that way, the EC chip will start up the motherboard. We check all the power supplies. If everything is okay, this chip is powering on the motherboard and posts the signal to the screen. Because this chip is also communicating with the screen through some signals which are going via LVDS. We have the LVDS connector which is connecting the motherboard with the screen. So this chip is doing a lot. Trust me, when I say a lot, it's doing a lot. It's handling almost everything on the motherboard. So most of the problems, when you don't have 3.3 volts, this chip can be faulty, this regulator, or this chip can be faulty. On some Lenovo laptops, some Lenovo motherboards, what I found we have 2 wires on the plus, 2 wires on the minus, and we have the middle pin. On some models, the middle pin is going straight to the EC chip. On some kind of Lenovo motherboard, not all, some kind of Lenovo motherboard, the middle pin, which is there to identify the charging current and is communicating with the BQ chip, they put a link between the charging port on the middle pin straight to the EC chip. In that way, you don't have to play too much with the charging port, because if you short the plus with the middle pin, this chip is going short on many times on Lenovo laptops. So this EC chip, we have many types of EC chip. We might have ENE, We might have I.T.C, we might have Lenovo, we might have Novatone, we might have SMC, we might have SMSC. We have so many kind of chips, but all they are doing same thing. On new laptops, motherboards, this BIOS chip is not external. It's inside this chip, and in that way, if this chip is gone, if you have to replace the EC chip, you have to reprogram the chip. On some new model of laptop motherboards, you have to replace with the same chip that is programmed. Otherwise, if you just replace with the same chip which is not programmed, the motherboard is not starting. Okay? So, how we are checking if this chip is fault? How we are checking if this chip is fault? We have some motherboards here. And we have another motherboard here. These are motherboard for space. So, we have here, we have E&E, that's the EC chip. And the next, we have the BIOS chip. Diet mode. Now, what we want to do is to check if the last pin of the BIOS chip, we have pin number 1, pin number 4 is ground, and pin number 8 is the VCC pin. From this pin, we must have a link with the EC chip. And here, we don't have a link. We don't have a link. So, that's not a big deal. If you don't have a link, that's not a problem. Because if we check around this EC chip, we have some ceramic capacitors. You have to find like 2-3 capacitors in common, and you check from the plus of those ceramic capacitors to coil. That's the way to see the 3.3 volts power supply. Maybe you want to locate the 3.3 volts power supply. You have to find some capacitors in common. Like these ones. These ones. You know what? Let's go under microscope. Let's go under microscope and have a look on what I'm saying. That's the microscope. That's the microscope. And what we are checking here, we have E&E, we have the BIOS chip, and the EC chip. The last pin of the BIOS is not going to this chip. And now, at this moment, you are wondering, how am I going to locate the 3.3 volts power supply? It's very easy. We have some capacitors here. You see those ceramic capacitors? This is ground, this is plus. And from this capacitor, we want to find another capacitor in common. We have this one. We have this one. It's beeping here. And it's also beeping here. And this is not ground. So from this plus, you can check with coils. You can check with coils to see where is the 3.3 volts power supply. Let's do it that way. Let's locate the 3.3 volts power supply. From here, we must have common points. We don't know anything about this motherboard, but we need to locate that regulator, which I was talking about. If it's not going to coils, you check with the chips. Somewhere, somehow, we must have a link. Somewhere, somehow, we must have a link. How can I do it? And it's going on the other side. It's beeping here. Let's pay attention to the chip. It's beeping here. It's beeping exactly to this driver. Let's see what driver do we have here. What are you seeing here? Huh? What do you think is this driver? Check on the screen. This is 51225. That is the 3.3 volts power supply. Here, that's the driver. Because we have this driver, we have some MOSFETs here. And on the other side, we have coils and two output capacitors. Those are electrolyte capacitor on the output. So we have these two outputs. And here on the chip, we must have other two outputs, the VREC 5 and the VREC 3. So that's the thing. That's the thing. So if you don't have a BIOS chip, just check like 2-3 capacitors in common. And from those capacitors, you try to check to coils. If it's not beeping to coils, try to locate the chip. Here we have another one. That's a different motherboard. We have the E.T.C chip. You see that chip? We have some capacitors here. Those capacitors, we have to check. We have to check. We have to check here. Here we have a BIOS chip. Let's check from pin number 8 here to the EC chip. And there's no link. There's no link between pin number 8 of the BIOS chip and this chip. That means this BIOS chip probably is the BIOS for the PCH inside this processor. But this is some kind of SAS single chipboard with the processor, which is an all-in-one processor. And inside that processor, we have the PCH, we have the graphics under one chip. That's not a big deal. All what we have to do is to try to check on those capacitors which I told you. Here's beeping, and here's beeping. So from this capacitor to coils, what about here? Because you have to locate the 3.3. If you are able to locate the 3.3, trust me, you can fix many laptop motherboards. Because from here, from these capacitors is going straight to the VREG 3, which is the driver for 3.3 volts and 5 volts power supply. If you can't find it on this side, you have to check on the other side. You have to check on the other side. I'm trying to locate the 3.3 volts power supply. If you can't get it on course, try to check to the chips. Okay, we have another way to locate this chip. If I can't find it here, let's check from the output of that. We have a switch on the USB ports. From there, and it's beeping here. So probably what is happening, my probes, they are not touching, but this is a 3.3 and 5 volts power supply. I'll show you on a microscope. But I'm sure that's the one. Maybe my probes, they are not touching. Let's see. Here we have a power supply. You see that power supply? We have two coils. We have two coils, 4 MOSFET, output capacitor, and the driver. This one. And here on the USB, we have this switching MOSFET, which is supplying 5 volts to the USB. From the output of this chip is going straight here. So if this chip is supplying 5 volts for the USB, that is the same chip which is handling the VREC 3 for the EC chip. Fine. Let's look at different motherboard. Here we have Lenovo, and this is a BGA EC chip. And trust me, these are some kind of new laptop motherboards, new models. And this chip, you have to have some skill to do reballing of this chip, because it's some kind of different. We have to know the necessary step to replace this chip in case it's fault. But the procedure is just the same. The checking procedure is just the same. You see those capacitors, they are linking. They are also linking. So from this capacitor, let's check the 3.3 for this one. Let's check the 3.3. I'm eager to know how the 3.3 on this motherboard might look like. We have many chips on the other side. Let's see if this, we have 2 BIOS chips here. All the VCC of the BIOS, they are together. What I want to do, I want to know from pin number 8 whether it's going to the EC chip or not. No, it's not going. It's not going there. So let's check the 3.3 on the other side. I'll do this here. I have to do this. I don't want to move the board. And it's going to this chip. You see? 0, 0. You see here on the multimeter? The link is going here, 0. So here is beeping here. It's beeping here. The motherboard, of course, is very dirty. But for the purpose of knowing the 3.3 volts power supply, so these are some kind of new laptop motherboards. You see, we have 2 cores and we have chip, no MOSFETs. Why? Because the MOSFETs are inside this chip. Inside this chip, we have 2 MOSFETs. Inside this chip, we have 2 MOSFETs. This chip is together with this core, and this chip is together with this core. This is managing the 5 volts, and this one is managing the 3.3 volts. And from this chip, we have the VREC 3, which is going straight here. Which is going straight here. So that's the thing. That's the thing about EC chip. That's the thing about EC chip. You have to know how to check if the EC chip is shorted. If you check those capacitors, those ceramic capacitors, which I said they must be in common, if you check, one side must be plus and one side must be 3.3. And the resistance of 3.3 to ground should not be to ground. And if the capacitor is beeping both sides, you check 3-4 capacitors, they are beeping to ground, there you have a problem. So either the problem is coming from the EC chip or from the 3.3 volts power supply. So yeah, I think I explained many things. So I think someone has learned something about how the EC chip is working, how to locate the 3.3 volts power supply. And yeah, just to recap, this chip is managing all the power supplies. That's point number 1. And it's also managing the screen. Because from this LVDS, we have a screen cable which is connecting the motherboard with the screen. And this low voltage differential signal, LVDS, is sending some signals to the screen. After you are pressing the power on button, the EC chip is running the startup test. It's checking all the power supplies, checking everything, is reading the BIOS, is doing a lot of things. If everything is okay, the motherboard will start. The motherboard will start, and if some of the signals from this chip they are missing, the motherboard, it will start, but it won't post anything on the screen. Because this chip is also managing the PCH, is also managing the GPU, is also managing the RAM power supply. Okay? So this is just the food, just the food that I've put on the table. It's up to you to take it or leave it. But I thought this can be a good moment to answer some of the comments which I've seen from the channel. Because a lot of people, they found it easy to bring back the 19 volts to life. But when it comes to 3.3, there is the issue. There is the issue. So if you really take these steps, you'll be able to identify the 3.3 power supply, and you'll be able to check what's going on with the 3.3. Because in most cases, most of the laptop motherboards, they come from the EC chip, or they are related with the EC chip. Because this is always under the power from the VREG 3. So if anything happened, the EC chip is dying many times. I found many laptop motherboards with dead EC chip. And you only have one option. You can't bypass this chip. You have to replace it if it's faulty. Okay? So, yeah. What I will say, what I can say, like, subscribe. Don't forget to turn on the notification bell for future updates. Also share our videos to your beloved ones. And I would like to take this opportunity to thank everyone for supporting the channel. I can see people, they are sharing my stuff across the continent, across the globe, across the world. Yeah. It's good to support one another. And our channel, this is not my channel, this is our channel. because without you guys, this channel is pointless. And I'm not 100% perfect. I've done a lot of mistakes. I've done a lot of things which are very wrong. But people, they still have patience that someday we'll reach there. So thank you for the support. I love you all, guys. And also, if you have not yet subscribed, just subscribe and turn on the notification bell so that you won't miss any updates from the channel. See you on the next one. Bye.